Kia ora tātou, welcome to this video where we'll look at electron configurations, and we'll be replacing, in some respects, some of the things that we learnt in Year 11. So let's have a look at what we learnt in Year 11 for electron configurations. We would have taken an atom, let's say we took nitrogen, which has 7 protons because the atomic number is 7, and we would draw it like this with 7 protons in the nucleus, and then we'd do 7 electrons around the outside of the atom. 1, 2, 3, 4, 5, 6, 7. And that was really useful. We learnt that when there were lone electrons, that would relate to the number of covalent bonds that it could form, and then for atoms and for elements in group 1 or group 17, we learned that they would either need to just gain 1 electron or lose 1 electron to form a full outer shell. So all of that logic is holds really true, but the problem with it is that on an atomic level, it looks as though these electrons are just orbiting the nucleus in a way that like planets would orbit the sun, and that doesn't work in that respect. The other thing is that whenever we were asked what goes on with the transition metals, we would have to say it doesn't work for transition metals, this kind of octet rule. So we're going to learn the more advanced theory, which kind of replaces some of the things that we've learnt, and that will hold true for the transition metals this time as well. One thing that we'll keep in mind really well is that if we think of these shells that we had in Year 11, think of them as energy levels. Energy levels, that kind of holds pretty true. And so this one would be energy level 1, energy level 2, energy level 3. So that the periods still represent energy levels in this respect. So let's look at, so it's not, we're going to find that it's not orbitals like planets orbiting the sun, that electrons orbit the nucleus. They have orbitals that look more like this. So we've got a spherical shape, these shapes here, however you describe them, and all of the ones down below. So the names of these orbitals are, we've got an S, and the category of these are called subshells. Subshells. And these are the orbitals. So there's the S orbital that looks like the sphere. There's the p orbitals that look like this. We've got d orbitals and f orbitals. We won't need to learn about the f orbitals for this course, so that's another thing that you can just taihoa until you get to university. So each of these orbitals can carry 2 electrons. So we can have 2 electrons within an S subshell. For a p subshell, because there's 3 orbitals within a p subshell, we can carry 6 electrons, and with d subshells, because there are 5 orbitals, we can carry 10 electrons in that. The other thing that we need to know is that with our energy levels, so which period an atom is in, there are different subshells within each energy level. So energy level number 1 has just got the S subshell, that's it. Energy level number 2 has got the S subshell and the P subshell, and that's making sense if we look at the periodic table again. So on the first energy level we've just got the S orbital, so it only fits 2 electrons, so there's only 2 atoms that can fit into there. The next one's got the S orbital, so those ones, and then also the P orbitals, which have got those 6 atoms can fit into that one there. So this is all making sense when it comes to the periodic table. For energy level number 3, we've got the S, P, and D orbitals, and so those D orbitals are now these 10 atoms, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 10 elements that fit into the middle. So this section correlates to the D subshell and the D orbitals. This section correlates to the S. I just thought I was doing that. And this section correlates to a P, the P subshells. So there we go. Yeah, so we've got 4, energy level number 4 would have S, P, and D as well. So let's look at how we do the electron configuration of an element or of an atom. So the way that we will do that is drawing out just what I've done here. We need to look at how we would fill these orbitals, because it doesn't go in a completely linear order. So we've got the S subshell for energy level 1, we've got the S and P for energy level 2, S, P, D, 2, 3, 4, and then S, P, D. We'd only ever get up to here maximum, just FYI. So if we were to do the electron configuration of nickel. So nickel has an atomic number of 28, so we're going to put in 28 electrons. So the way that we draw that is that we put these together, the energy level and the suborbital. So the energy level is 1. I'm going to move it over a bit so we've got a bit more room. 1s, and then on the superscript we put the number of electrons in that orbital. So there's 2. So we've used up 2 electrons. We've now got 26 left. And the next energy level we're going to go, so that we've used that up. And this diagonal arrow, you'll see the significance of that in a minute. In the second energy level, we've got the S orbital, so S, 2 electrons, so we're down to 24. And then we go the P orbital, and then we follow the arrow. We go from the P to the S, so 2P, 6, 3S, 2. So that's now 8 more used up, so we've got 16 electrons left. Now we're going to, and notice how we're going to skip the 3D and go straight to the 4S for this one. So we go 3P, and we use up 6, so we're down to 10 electrons. And then the 4S, and I'm just going to leave a bit of a gap, because even though we fill the 4S first, we still write them numerically. We still write the electron configuration numerically. So that's taken us down to 8 electrons left, and because the d orbital can fill 10 electrons, we're going to go 3d, and we can put the rest into there, which is 8. So that's the electron configuration for nickel. Let's have a look at one more. Why don't we do titanium? So titanium has the atomic number of 22. So we go through and do all of this again. So 1s, 2, 2s, 2, 2p, 6. So we've used up 10, so we're down to 12 electrons left. And then we'll do 3s2, so we're down to 10. Then 3s2, 3p, 6. So that's going to take us down to 4. Then we'll do 4s2, so we're down to 2 electrons left, and we can go 3, use up the last 2 in the d orbital, or the d subshell. Hope that makes sense for you. Hope that's not too devastating to learn that what we had in year 11 wasn't entirely correct, but it's very satisfying to be able to do the transition metals now as well. So if you just, in every exam there will be questions looking at doing the electron configuration of atoms. In the next video we'll look at how to do the electron configurations of ions, which isn't too much more difficult, but there's just a little bit extra that we need to add. Thanks very much for watching. See you next time.